Let's take a look at vertical asymptotes of rational functions. We're going to be spending a lot of time talking about asymptotes, and those are going to be lines where our graph is going to be approaching the asymptote, and a lot of times it's not going to cross or touch the asymptote itself. We will talk about a couple special cases where the graph is allowed to cross through one of those asymptotes. When we go to draw them on the graph, we're going to draw them as dashed lines. So if you want to make yourself a couple little notes, these will appear as dashed pieces. And if we're talking about vertical asymptotes, then obviously our vertical ones are going to be going up and down, and they're going to be in the form x equals some number. So let's go ahead and take a look at our two questions here. For the first one, we're asked to find the vertical asymptote of r of x equals 5x squared over 3 plus x. And asymptotes are going to come from the fact that we're not allowed to have 0 in the bottom part of our fraction. Okay, so this is going to be a spot where we're going to take that denominator and we're going to set it equal to 0. So in this case, we've got 3 plus x equals 0. And I'm going to go ahead and solve this for x, so I'm going to subtract 3 from both sides. And this will give us an x value of negative 3. So our vertical asymptote, I'll abbreviate that as VA, is the equation x equals negative 3. Make sure you list it as an equation. It's not just a number, right? It's a line. So when we go to draw the graph, right, at that x value of negative 3, we're going to draw the asymptote as a dashed line through that. And we'll take a look at what the graph looks like here in a second. Let's go ahead and take a look at the second example. This time we have a function h of x. We have x minus 3 on top, and on the bottom we have two sets of parentheses, x plus 2 and x minus 2. Same idea, we want to go ahead and take a look at when our denominator is equal to 0. This one's already factored for us, which is really nice. So we'll go ahead and set each factor equal to 0, and then we'll go ahead and solve each one so that we can get some x values. So we've got an x value of negative 2, and we're going to get an x value of positive 2. Right, so if we go to give ourselves a little sketch here, at positive 2 and negative 2, each of these are going to have vertical asymptotes through them. And if we drew the graph, it would sit in 3 sections. You'll have a piece over here in the left region, one in the center, and one on the right-hand side. We'll go ahead and take a look at those graphs. So I went ahead and graphed both of these. So let's take a look at that first function that we were working with. All right, remember we said we had a vertical asymptote at the line x equals negative 3. Right, and you'll notice that on our graph it's drawn here as our dashed line. And the function itself, r of x, is graphed in red. Right, and we can start taking a look at domains and ranges, where the graph is increasing or decreasing. We can still go back and talk about intercepts, both x-intercepts and y-intercepts, off of our graph. Right, and if we take a look at that second function that we worked with, this one we had 2 vertical asymptotes. Right, we had one at the line x equals negative 2, and then we had another one at the line x equals positive 2. Right, so these are drawn as the dashed or dotted lines on our graph, and the function h of x is drawn in red. So you'll see that it sits in the 3 regions there. Right, you have a portion of your function on the left-hand side, you have a red portion in the middle, and then you have a portion on the right-hand side.